Producers and distributors of Tech AV training material welcome you to part 2 in this series on using an analog oscilloscope. In this program we will discuss calibrating the voltage attenuator of the probe, amplitude or voltage measurements, time or frequency measurements, pulse width and duty cycle, and rise and fall times. Let's begin with calibrating the voltage attenuator of the probe. Attach the probe to the probe adjust facility on the scope. Remember that the amplitude of a signal is displayed by a deflection of the trace up and down the screen and is expressed as a voltage. In preparation to measure voltage, switch the input coupling switch to ground and adjust the vertical position control so that the trace is superimposed on the second lowest horizontal graticule line. Switch the input coupling switch to DC and count the number of divisions from the bottom to the top edge of the waveform. Now multiply the number of divisions by the volts per division setting to calculate the voltage of the square wave. Your answer should be 50 millivolts, but as the probe attenuator is set to the times 10 mode, the actual voltage measured is 500 millivolts, or 0.5 of a volt. Since the probe adjust test voltage is specified as 0.5 volts, the performance of the probe is within the manufacturer's specification. Now switch the attenuator to times 1 and adjust the volts per division control until the waveform fills the screen again. Confirm that the signal voltage is 0.5 volts peak to peak. In conclusion, always ensure that the variable volts per division control is in the calibrate position when measuring an unknown voltage. Let's continue as we look at two general types of voltage measurement, namely instantaneous peak-to-peak values where the exact voltage is measured from each and every point with respect to a ground reference, or peak-to-peak values where the total amplitude between two extremes is measured without regard to a polarity reference. This is the operating procedure when taking an instantaneous voltage measurement. The scope is fed with a square wave signal derived from the test signal generator. Switch the input coupling switch to ground and adjust the vertical position control so that the trace is superimposed on a suitable horizontal graticule line as shown. Switch the coupling switch to DC and using the volts per division control, adjust the vertical deflection so that the complete waveform fills the screen. Adjust the time per division control to display 2 to 3 cycles of the waveform. Adjust the horizontal position control so that the upper trace intersects with the vertical center line. Now count the number of divisions and subdivisions between the upper and lower edges of the square wave. Calculate the instantaneous voltage of the square wave by multiplying the setting of the volts per division control by the number of divisions. The calculation is 6 divisions times 2 volts per division equals 12 volts. Owing to the regular repetitive pattern of this square wave, the instantaneous value of the waveform is either 0 volts or 12 volts. Complex waveforms will have many different instantaneous voltage values, as the diagram shows. To summarize, the instantaneous peak-to-peak voltage is the exact voltage measured from any point on the waveform to a ground reference. After the break, we'll discuss the measurement of a peak-to-peak voltage.